So, folks, hopefully you've been able to follow our example here and take a minute to do this one as well. Choose those same 10 points, but this time plug in your serving size as opposed to the grams of fat. So, I'm not going to do this one in its entirety, but if we were to go back and do our serving size, that would be 130 grams to 380 calories. So, really, this second column here should remain exactly the same because of the fact that we're plugging in the same points. But instead of grams of fat, we're now taking grams of the serving size. So the serving size there would be 130, and then the grams of the calories in that case was still 380. So take a minute to go ahead and practice that one as well. The more we practice, the better we're doing. Um, the last component that I wanted to look at with you guys today is if you flip over to the back of your, or to the next sheet rather, if you go to the next sheet, I have another example here that I hope you guys will understand as well. In this case, our question is looking at the age of a car. So across the top there we have 1, 2, 3, 4 to 8, and that's basically okay. It's 1 year old, it's 2 years old, it's 3 years old, so on and so forth. And then we have the value of the car. So in this case, the value of the car is in thousands. So your car isn't $24, it's $24,000. That's the first thing that I would kind of note. And we've already gone ahead and done the graph for you in this case. So you can see that this is definitely a very linear function and definitely going in the negative direction. So it has a negative correlation, no doubt about that. But the reason why this is so valuable is we could now use this um, information to try and predict how old or how valuable our car is going to be in a certain amount of time. So we're going to go ahead and find this line of best fit to get started. But before we do that, I want to kind of talk about what domain is and what the range is of this function. So if you remember, I've got my graph kind of here in the down bottom right hand corner. But when we talk about domain, we're always talking about the x variable. So our x variable, which in this case, our domain is the age of the car. So if you want to think about that, you have to think about the fact that since this is the age of our car, can the age of our car ever be negative? And the question to that is a definite no, right? You can't have a car that's negative 3 years old. No way, no way. So our age has to be basically bigger than zero. The minute that car is made, it starts getting older, right? So our age can't be negative. The next thing is, can it go as high as it possibly wants? So technically, that's like a sort of a yes, because you could have a car that is really, really, really old, but you're not going to have a car that's, you know, 1,000 years old. So there are some limitations to that. So I want you to kind of keep that in mind, that there are really some limitations here. So having a good understanding of what the domain means is important. Same goes for the range. In this case, the range of our function is the value, or how much that car is worth. All right, the value of that car. So if we're going to look at the value of our car, can the value of our car really, how low can it go? Okay, what's the lowest value? What is the lowest value that it could be? Well, really, eventually our car might be worth $0, right? It might be worth $0. Maybe not. Maybe you can sell it for parts. I don't know. But really, it can't go any lower than zero, which means that's AKA no negatives either, right? So no negative here as well. But what about the highest our value could go? Well, the highest point is usually for most cars, usually is the moment that you buy it. All right. It's the moment that you buy that car. That's usually our highest value. But there are a few examples where that value actually starts to go back up. And that would become if you ever had a classic car, like a really old Corvette or something that's the car has become a classic. I'm not a big cars guy, but I know a little bit about it. So last but not least, we've kind of already talked about this one. What type of function this is? Well, this is definitely making a straight line, so it's definitely a linear function, no doubt about that. The direction, we've talked about the direction as well. It's definitely going in the negative direction. And how strong do you think this is? How strong of a relationship do you think that is? Well, looking at our line, there's very little deviation here from that pink line. So this is a very, very strong relationship here, a very, very strong negative linear correlation. Okay, so that's just kind of our prep work there to get that ready. Now what we want to do is find that actual line of best fit. So go back to your table and plug these points here at the top, plug these points here back into your calculator using the age for X and the value for Y. Okay, make sure you don't plug it in thousands, just plug in 24 and 21. Press pause. I've already done it here on my calculator. So go ahead and press pause while you plug those data points in. All right, so here we go. I've got my data points plugged in. I want to find my line of best fit. So I'm going to click Stat. Then I'm going to click Calc. Then I'm going to go down to LinReg and hit Enter. Go down to Calculate. All right, click Calculate. And our linear regression is negative 2.476. So if I round that, let's see here, my line of best fit is y equals negative 2. Let's pull that back up because I already forgot it. Negative 2.476. So 2.48x. If I round, I'm rounding that 8 up. Okay, and then plus, what's our y value? Our y-intercept is 26.64. So 26.64. There's our line of best fit. Very important, though, that we interpret the slope of blank, what our slope was. What was our slope? Our slope was negative 2.48. We want to interpret that in the context. So think about that for a second. I want you to turn to your neighbor. Tell them, what do you think that means? To me, what it means is that our value, first of all, the value is decreasing. It's decreasing because the slope of our line is negative. So it's decreasing. Well, how much is it decreasing? It's roughly decreasing $2,500. Think about that. 2.48. That's roughly, if in thousands, that's roughly 2,500. I'm just rounding. $2,500. Well, how often? It's roughly decreasing $2,500 per year that we own the car. That's what the slope really, really means in the context of the question. From there, we now look at our y-intercept, 26.64. So let's just round that to maybe 27. That's our starting amount. That's our starting value. So when we drove the car, when we bought that car, we paid roughly approximately $27,000 for that car. That's what the y-intercept means. Press pause if you need to talk that over with your neighbor. Now, the last part is to decide, well, what's the relationship? Well, there's definitely, we've talked about this, definitely a negative relationship, and it is definitely a strong one. We can see that by looking at the calculator and seeing that our R value is negative 0.99. That's really, really strong. And then last but not least, we're going to use this equation to predict. And this is the part that you don't know how to do yet. So grab your calculator, and we're going to take this equation and we're going to type it into y equals. So everyone on your calculator, I want you to click this key here at the very top. I'm looking at my mouse. Very top. Y equals right there. Okay? And you're now going to type this equation into the calculator. And I'm running out of time here, so I'm going to type it in very quickly. Negative 2.48. Okay? Negative. Oh, all right, I'm going to do this in the next video for you.